Look at our robot. Now back at me. Now back at our robot. Now back at me. This is not your robot, but it could be. Monty is no pretty robot, no statue of David, you might say. But he has a job, and he does it well. Here at Group Run Robotics, we, Troy,
Jack, Nathan,
Josh,
take our job seriously.
you need your robot to follow a line. Problem, it can't just follow the line, that's too easy. Not only does it need to detect and react in a dynamic environment such as corners, start and stop markers, speed limited zones, and intersections of different lines, it needs an optimal mechanical design with a balance between speed and maneuverability so you can complete a lap of the track in a timely manner. You need sensors to detect the changing environment and the code to react appropriately. What's more, you want your robot to learn, to adapt to the course as it progresses to improve its final time. Team 1 Robotics can give you the solution you need to your problem with our little trooper, Monty.
Following a line may be easy for you and me, but for little Monty here, a lot of work went into getting him on his wheels. 5 main subsystems were focused on to get the robot this far. Wheels and motors, the chassis, sensors, power, and of course, the programming. Through very complex and detailed wheel and motor calculations, we achieved a theoretical top speed of 50 centimeters per second, soon to be tested in real life. This speed requires quite a bit of power, and to supply the robot, 6 1.5 volt AA batteries are used due to their low price, reliability, and ease of acquisition. The other key subsystem which requires power is the sensors. 6 specially designed infrared light sensors were utilized to detect a line with sufficient resolution to allow correction capabilities. Another sensor is positioned to the right to detect start and stop markers. An additional enhanced color detecting sensor is positioned to the left to spot corner markers and speed zones. To fit all of these components together, a chassis was designed and laser cut from wood for its low price and strength. And of course, the subsystem that integrates and controls it all is the programming in the microcontroller.
So far, the project has seen the advancement from simple black, white, and color sensors and basic motor control to a prototype tethered to a simple power supply performing speed and direction changes. Through the use of an enhanced regulated power source, the robot has gained a degree of freedom, enabling the use of computer code to improve its ability to follow the line at greater speeds. Through the use of advanced design techniques, the chassis and PCBs were designed using SolidWorks and Eagle software. Into the future, further sensors will be incorporated into the main robot, such as color detectors to determine the locations of the speed zones, wheel encoders to control the speed of, and computer code to determine the difference between start, stop, and speed zone markers. Through management and backlog tracking, we will be able to deliver the project on time.
To build the best bot your money can buy, we split the enormous task of designing a line-following robot into multiple smaller tasks. We call these tasks sprints because we are intent on a bright and healthy future. An example of these tasks is the completion of a prototype sensor, including programming, ordering and purchasing, and physically building the sensor board. Together as a team, we beat down these tasks by meeting every 2 days in a manly event we called scrums, because we are intent on being active and supportive. During each scrum, we discussed how our time was spent and what nasty little problems came our way. We also delegated jobs and sorted our problems out in a peer-to-peer fashion. A number of these problems included multiple faulty components, numerous coding errors, and a few select design issues. These problems were rectified through hard work and dedication to our task.
Look back at Monty. Through your continued funding, you will see Monty improve in leaps and bounds, seeing the second prototype finished and the final product manufactured. Thank you for giving us your time.